Okay, quadratic formula, problem 1. I already took the liberty of setting it equal to 0 and picking off the ABC. A, B, C. Make sure it's equal to 0 or you're going to have your signs wrong. Now again, just plug in negative b plus and minus. You need to do b squared minus 4ac. That whole thing over double A. A is 3. Whoops, it helps if I put the right number there. There we go. So on top, well, let's see if I can fit it there. Negative 2 plus and minus. Now you have to do 2 squared, which is 4. And then minus 4 times 3. How about I just do this whole thing correctly? 4 times 3 is 12, times 2 is 24. I don't need my thing that long now. And then on the bottom, you have a 6. So inside, you're going to have negative 20. So you have negative 2 plus minus radical negative 20 all over 6. Now it's going to go quick. I'm going to break the negative 20 down. So my discriminant, the b squared minus 4ac part, is negative, which means I'm going to have imaginary complex roots. Take the negative outside as I, split up 20 with 4 and 5. You need a perfect square, so you need to use 4. Now, 4 comes out of jail as 2. You hook it up with the I that's waiting for it. Radical 5 stays in jail. You can't do anything with that. Now, you have a 2, and a 6. Everybody's out of jail. You don't care about 5. He doesn't get messed with. He's in jail. Cut them all in half. That becomes negative 1. That becomes 1i, and that becomes a 3. Nothing else you can do, but you do have to simplify. If the numbers reduce, you must reduce. So again, just cut them all in half. They're all even. Divide them all by 2, and then stop. Do nothing else. That's your answer, okay? Okay, question 2. It's not equal to 0. So I'm going to do plus 1 to that side. Make it equal to 0. That means that A is 2, B is negative 6, and C is positive 1. So now again, plug in, just be very careful. The formula says negative B. So that's a minus minus 6, plus minus. Now I'm going to have to do negative 6 squared. Make sure there's parentheses here. It's not right if you didn't do that. Minus 4. A is 2, and C is 1. That whole thing over twice A. 2 times A is 2. So negative 6 is plus 6. Negative 6 squared is 36. Minus, well, 8. Again, I went too far. 2 times 2, 4. Pow. Inside the radical, you're going to have a 28, right? 36 take away 8. You don't have to do any of this crap in your head, by the way. This is what you have a calculator for. Use it if you need it. 28 breaks down with 4 and 7. Right? Perfect square. It's 14 and 2. It's not 14 and 2 because 14 and 2 are not perfect squares. 4 comes out of jail as 2. Radical 7 tags along for the ride. 4 is on the bottom. But now look, again, you have a 2, a 4, and a 6. These are all even numbers, but 7's not even. 7's in jail. The guy in jail doesn't count. This is one thing. This is one term. One term, and then they're being both divided by 4. So cut them all in half. Half of 6 is 3. Half of 2 is 1. You don't have to write it if you don't want to. If it makes you feel better, put a 1 there. You know, you can put a 1 in front of that radical 7. That's it. Don't do nothing else. Don't get cute. Don't get fancy. This is exactly what I want. Every step that I wrote, you must write. Cannot skip any of the steps that I wrote. In particular, a lot of people, too many people are going from here to here. This is not acceptable. You are going to lose points for it. You must show me how you broke it down and then took the guy to jail. Okay, question 3 on the quadratic formula worksheet, well, quadratic equation worksheet 4. Again, lighting not so great, and I'm trying to repair the broken video. So again, different color. Board's bigger, but same deal. This must be equal to 0. So that 3 has to come to this side. You switch it, right? You subtract 3 from both sides. Now you got to pick the A, B, C. A is 4. Now, B is trickier. It's like There's nothing in front of the x. There's a -1 in front of the x. And c is the number all by itself. Number in front of x squared, number in front of the x, which is -1, right? There's an invisible 1 there. And then the c is -3. Now you just plug in negative b. B is -1, so be careful. Plus and minus b squared, but that's -1. Minus 4. Got to extend my radical there. A, C. And remember, the whole thing, don't just put the line under here. 2A. So there you go. Now the rest of it is just keeping track of everything real careful. Negative and negative is plus. -1 squared is +1. I know I'm going to have a plus. You have a negative, a positive, and a negative. These two negatives make a plus, so I'm just going to put the plus down right now. 4 times 4 is 16. 16 times 3 is 48. If you can't do that one, do 4 times 3 first. 4 times 3 is 12. 12 times 4, 48. Or you just cheat, use a calculator. Now again, remember, the line goes over here, not under the radical. The line is under the whole thing. On the bottom, you have an 8. Now, something really weird happened here. 1 plus 48 is 49. And that's a special number. That's a number we know. That is a perfect square. It's going to come out of the radical. So you got to take it out of the radical. So you're going to get 1 plus or minus 7 over 8. Now, a lot of people left their answer like that when I was grading them. Remember when he did the upload? This is fine. I wouldn't mark this wrong. But since the radical disappeared, you can certainly take 1 plus 7 over 8. And then you can do 1 take away 7 over 8. So here you get 8 over 8, otherwise known as 1. And here you get -6 over 8, otherwise known as -3 over 4. Now, if you didn't do that or finish that, that's fine. This tells me the original problem factored. I would not have gotten numbers like this. I would have answers with radicals in them if the original problem didn't factor. But since it has nice numbers with no radicals, I know the original thing did factor. I could have factored that and got the same two things. But it didn't say solve by factoring. It said solve by square root. So you had no choice but to break it all the way down. I'm not going to have a heart attack if you stop there. I wouldn't give you one like that anyway, because what would the point be? I want you to use the formula and simplify. All right, so that was 3. I'm going to do 4. All right, number 4. Now I'm going to point out something. You have a negative in front of that x squared. You can change it, but the thing is, this isn't the original question. Now, if you were to do that, when I ask you one like that, I would have a problem with that, and I would deduct points for that. The question does not say, alter the thing into something different and then use it. It says solve by quadratic formula. So you have to apply the formula to what you see in front of you. I don't want the question altered. So the a in this case is the number in front of the x squared, which is a -1. The number in front of b is a 4, and then the number by itself is -5. It's already equal to 0, so I can just pull the numbers off. If you switch them all, this would be a 1, a -4, and a +5. That's not the problem I gave you. So you're not allowed to switch the signs here. All right, so you have to leave this alone and do it in the way that I give it to you, unfortunately. It doesn't make it that much nastier, except at the end, you have a little bit of trickiness to deal with. So plug in -b plus or minus, same thing, b squared, -4. I never draw this long enough. A, C, and then again, the whole thing over 2a. Formula is right there for convenience. I left it there. So -4 plus or minus, well, 4 times 4 is 16. I gotta be real careful here. You have a minus, a minus, a minus. I have 3 negatives. I know that 4 times 1, right? -4 times -1 is +4. +4 times -5 is -20. That's why I put the negative there. Now again, people make a mistake, they do this. This is not right. This line doesn't go here. The line goes across the whole thing. Right there like that. The -2 is underneath there and there. Now this is where I told you in class, this gets very tricky. I'm going to deal with this in a second. I'm not going to keep them like this. You would never keep this answer. You know, these two negatives make a plus. So I'm gonna fix that. I'm not going to leave that negative down here. I'm going to remove it with this one. But I'm not going to do it yet. 16 minus 20 is -4. Right? Just subtract. Now, I know this. It comes out. Now, I have -4, plus and minus. The negative comes out as I, and the square root of 4 is 2. So you're going to put a 2i here. Now I got to play my game. You're doing -4 over -2. That's +2, right? A negative and negative make a plus. Now, here's the tricky part. You're dividing a 2 by a 2, but it's negative. But who cares? Look, you have positive and you have negative. The negative and the negative make a plus, and the plus and the minus make a minus. So because of this double sign, you can just keep that there and just get rid of the 2, right? Divide this 2 by everybody. These negatives make a plus. This negative did not affect that because you already have both signs there. It's tricky, but the point is just don't mess with this. Just leave it as plus minus. Just take these two negatives and turn them into a plus. You could have did it here. That's fine. Either way, at the end, you're dividing everything by 2. So the 2 on the bottom goes away. So the final answer is just 2 plus or minus I. Okay, so in the original video I shot, I did 1 through 5. 3, 4, and 5 got broken. Now, even though this class, I only had us do 1 through 4, I'm going to shoot 5 as a bonus, just so you can see it. Because I did, my other class originally had to do the first 5. So I want you to see it done. Now, this factors. I know that I could just put 2x plus 3, 2x minus 3. And I know what I'm going to get. And I'll even show it at the end. A is 4. Now I need to do B and C. The problem is there is no B. There's no x term, right? It's ax squared plus bx plus c. But the b is missing, which means you have to put a 0 for it. And then the c is the number by itself. Now this is going to go real quick. This is going to be wacky. You got negative b, okay, plus or minus b squared, okay, minus 4, I never make that big enough, 4a, c, all over 2a. Okay, well, that's 0. That's 0. I don't like the way my plus looks there. I'm going to do it again. It's annoying me. There you go. Prettier. That's a 0. Negative and a negative is positive. Now, 4 times 4 is 16. 16 times 9 is, I think, 225. I don't do this crap. So, just making sure. Oh, 144. All right, yeah, see, I know what the hell I'm doing. It's too big anyway. Use the calculator. I just did. So, what I should have did is 36, right? 4 times 9 is 36. And now I just have to double that twice. Right? When you times something by 4, you double it twice. So that's 72 and then 144. I should have done that, and then I didn't look like a moron saying 225. So 0 plus 144. You know what? Do it over here. So more room. That's gone. Right? There's nothing there. It's 0. So just don't even put it. Here you just get 144. And here you have 8. Now, perfect square. Right? It's 12. 12 times 12 is 144. So you're going to have positive 12 over 8. And you're going to have negative 12 over 8. But what are those numbers? I know you know those numbers. These numbers are divisible by 4. Right? 12, you know, this is what I show my remedial class. 12 is 4 times 3. 8 is 4 times 2. Cross out the 4s. You get 3 over 2. We're a little more sophisticated. We can do this in our head. 12 divided by 4, 3. 8 divided by 4 is 2. And then the other one is just the negative of that. Again, notice if we had just factored this, right? 2x plus 3, 2x minus 3, whatever, minus plus. Add the 3, divide by 2. You get positive 3 over 2. You get negative 3 over 2. Yay! Look, same thing. Obviously, you would never, ever, ever use the quadratic formula on something like that. You would solve that by factoring. Boom. I mean, you would never do this. But look, you get the same thing. It works. It works every time as long as you do it correctly. But this is a huge pain in the ass to do on a problem that factored. All right, so that was question 5, and that's all that I'm doing. So